Hello everyone, today's topic is Chebychev-Grübler-Kutzbach Criterion. This criterion is important for multibody simulation. The procedure is the determination the number of degrees of freedom in a kinematic chain when rigid bodies are connected by mechanical joints. The number of degrees of freedom of all rigid bodies in the chain is reduced with the number of joint constraints connecting these bodies. This is how you calculate degree of mobility F. The easiest way is to use formula 1 without ground body, or include ground body we can use formula 2, where F degree of mobility, M is movement tube, M is 6 when moving in space, M is 3 when moving planar or spherical, N, small n, number of bodies without ground body, or if you prefer use formula with ground body, 10n, big N is number of bodies include ground body, also plus 1. J is number of joints, and FA degree of freedom joint A. The result, F, is degree of mobility. If F greater than or equal to 1, then kinematic chain is executable. F1, 2, 3 and so on. Kinematic chain is force executable with 1, 3, 4 and so on drives. But if F less than or equal to 0, then kinematic chain is not executable. More constraints than necessary. Over-constrained. Exception are overlocked gearboxes. Here in table you can see some joints with degrees of freedom. Pictures are from OpenModelica and constraints. Example, prismatic joint has 1 degree of freedom, is translation, and constraints are 6 by moving in space, minus 1 degree of freedom is 5 constraints. For example, we calculate degree of mobility for simple kinematic chain with 3 bodies and 4 revolute joints. Movement tube is 6, moving in space. Degree of freedom by revolute joint is 1. With formula 1 we can calculate F. It is 6 multiplied 3 minus 20. Degree of mobility F is minus 2. Kinematic chain is over-constrained and not executable. We have more constraints than necessary for this construction. Another example, crank mechanism with 3 bodies, 3 revolute joints and prismatic joints. For movement tube 6 in space with 6 degrees of freedom, we have degree of mobility minus 2. This mechanism is not executable. We will look at this example in OpenModelica. We go in OpenModelica, connection editor, and start new model. First, define component word. After this, create first part body cylinder with vector x, y, z 0.5, 0.5 and 0 and diameter 0.1 meter. With copy and paste, add 2 more body cylinders. For the second cylinder, I change the vector to y minus 0.5. The third cylinder gets vector 1, 0, 0. This is the horizontal cylinder. Note of joints. Add first revolute joint and connect it with word and first body cylinder. After this, activate the velocity tail for this joint, constant velocity. Copy and paste first revolute joint. Deactivate velocity by second joint and connect it with first and second cylinder. After this, duplicate second revolute joints and connect it with second and third cylinder. Revolute axis is by all joints is Z axis. Finally, we need a prismatic joint at the end of third cylinder. Add it to model, connect to third cylinder, by parameters you can see axis of translation. Default is in X direction. Connect frame B to word. Simulation setup is okay. Save the model. And start simulation with animation. We get a message, translation error. Our model is overconstrained and not executable. What can we do? We need a reduction of constraints in the model. Possible solution is to use revolute planar loop constraint. Delete second revolute joint and add revolute planar loop constraint. Connect it with cylinder. By parameters, you can see information in comment. This joint is described by two positional constraints for usage in planar loop. Now we have reduced the constraints. Start simulation with animation again. You can see it works. Results here: blue are cylinders and red color are joints. Animate the crank. Attention, some simulation software by overconstraint problems simply remove any constraints and only give a warning message. It was for today. See you next time. Bye bye.